One of the images used at the public meeting that was held on November 20th at Nat Stadium first identified the traffic demand modeling. A table identified the volume for the different options during the PM peak period. It showed that 845 more vehicles would use option D than A. Option C identifies a volume of 1,120 more vehicles than option A. And 1,540 more vehicles would use option B than option A. Identifying the volume for option B1 or B2 would be 18% more than in option A. A question: is it incorrect to say that an option with more volume is more impactful? The large table on the right shows a micro-simulation of 25 different intersections in the region and identifies the level of service at those locations, comparing a no-build option to options A, B1, B2, C, and D. The objective of the Bridge and Parkway Options is to effectively and efficiently move the volume of traffic through our region. The table indicates that a level of service of E and F is considered failing, and that A, B, C, or D is functioning. A note above the table indicates the options A and D are the top two rated options for operational efficiency. Looking at the table located in the lower left-hand corner seemed confusing, not seemingly to clearly bear out the conclusions about options A and D. To investigate further, a point system seemed to be the method to statistically evaluate the levels of service at these 25 intersections. A single point could be attributed to LOS A and a value of 6 points to LOS F to create this new table. Using the associated numerical values, totals could be determined at the bottom of the table, such as how many service levels, either LOS A, B, C, D, E, or F, exist for all of the Bridge and Parkway options. For example, option A has a total of 8 LOS-D intersections. All of that information can be displayed graphically as a bar chart. Each option, including the no-build option, is displayed as a color. For example, option B1 is shown in blue. There are 6 sets of vertical groupings with levels of service for each of the options shown at far left. LOS-A followed to the right by LOS-B, LOS-C, LOS-D, LOS-E, and on the far right, LOS-F. Visually, this identifies that there are fewer numbers of E and F service levels, shown on the right, and that level D LOS is the most abundant level of service. As displayed on the presentation's initial slide, a breakdown of the types of level of service into 2 groups was created. One group has the desired delays, and one group has failing LOS. In this breakdown on the left, it is indicated that option A and option C both have 1 more A to D LOS, and on the right, 1 less EF LOS. This is an indicator that option A and C have fewer total delays, A and F, but by only 1 instance at one time. The organization Transportation for America, comprised of local, regional, and state leaders, has a slightly different description of LOS. Levels of A, B, and C are considered free-flowing conditions, and LOS-D is considered to have a volume near capacity, with speeds being considerably affected. LOS-D is defined as being less than or equal to a 55-second delay. It is interesting to see what will happen if there is an ABC group and a DEF group, splitting LOS levels in that manner within our region. It would appear in this scenario that options B1, B2, C, and D have the benefit of 1 more ABC LOS, with option A having more intersection delay levels due to the high number of level of service D. Again, all options are extremely close to each other in impacting delays at intersections. Looking very, very closely at the details in the table, the closeness of how all options impact the anticipated 2050 level of service is apparent. When comparing each of the options to the no-build option and viewing exactly at which intersections the improvements are expected, The total impact margins in our region are, again, razor thin. B1 and B2 have the total benefit of 4 LOS points. Options A and C have improvement at 5 points, and option D does best with plus 7 total points. It would be important to view the total number of points for all intersections for all the options to understand the ultimate impact of delays at these intersections. Adding up the point totals for all 6 level of service types, A through F, for all the options provides a range of values that are only separated by 3 total points, with 4 of the 5 options being separated by only 1 single point. In this method of calculating, the lowest point total values identify which options that are most favorably impacted. Option D proves to be the most impactful with 76 points, with options A and C close behind, and then B1 and B2 having a smaller impact by just 1 single LOS improvement. As you can see, there are many ways of looking at the results of modeling the level of service for the PM peak time period in the year 2050. Simply identifying that the implementation of any option will enhance overall operational performance seems to be sufficient, as opposed to highlighting that 2 options are the top 2, especially when all the options are almost identical in their overall impact of creating smaller delays at these 25 intersections.